Hello everyone. This lecture is exclusively recorded for second year BSc student of BK Birla College, Kalyan. This is mathematics class, paper 1. In this lecture, we will solve some example of Riemann integration. This session will be useful for practical solving, practical number 1 and number 2. So let me take few questions from the practical. So question number 1. So if f of x is equal to, it's given to be x if x belongs to close interval 1 comma 2 intersection with rational and 0 otherwise. Or you may say that all irrational number between 1 comma 2, or we can say that the irrational number between 1 to 2, right? So the question is, check the R integrability of f of x. So we have to check whether f is R integrable or not. So the way to check whether it is R integrable or not, one need to find out UF, one need to find out LF. If UF and LF both turn out to be equal, implies that it is R integrable. If they are not equal, then we can say that they are not R integrable. So let me calculate what is UF and LF. So to calculate UF and LF, I will be taking a partition solution. Let Pn, which is equal to, be a partition of close interval 1 comma 2. It is clear that f is function from close interval 1 comma 2 to R. So let me define this, have a partition of close interval 1 comma 2. When I say Pn, that means partition will I am dividing into n equal parts. So the first point of partition must be 1, then 1 plus 1 by n, 1 plus 2 by n, comma 1 plus 3 by n, dot dot dot, 1 plus n by n is 1, so 1 plus 1 is equal to 2. So this is well defined partition because first point is 1, last point is 2, and they all are in increasing order. So be a partition of close interval 1 comma 2. Right. So now just try to understand this function. Many a times we realize that students find it difficult to understand this question itself. So what question says, the function value is x if x is rational. Rational, when I say 1 comma 2 intersection with q, that means it means all the rational. What does it means? All rational number between close interval 1 to 2. क्लोज इंटरवल 1 कॉमा 2 के अंदर जितने सारे रैशनल नंबर होंगे, सो इंटरसेक्शन विद मींस दिस मींस दैट ऑल रैशनल बिटवीन close interval 1 comma 2. What does this mean? This says that all irrational number between close interval 1 to 2, between 1 and 2, I should say. Yeah. Rational between 1 and 2. Similarly, all irrational between 1 and 2. So, well, I am not writing that. it is understood be a partition of closed interval 1 comma 2. So let me define here my capital Mi as a supremum of fx. Fx such that x belongs to xi minus 1 comma xi. Small mi is infimum of fx such that x belongs to xi minus 1 to xi. So for all I goes from 1 to n. Right? So this is my basically x0, this is x1, this is x2, x3, this is xn. Right? So let me calculate, let me have a table here mi cap mi small mi and here interval, which we will call it as xi minus 1 comma xi, and we will try to find out the supremum, infimum and all. Right? So for the first interval is 1 comma 1 plus 1 by n. Right? So yeah, the x0 comma x1. So you could see that my infimum is very clear because it's 0 anyway. Otherwise my f of x is x and I need to find out the f of x is x always. So I need to find out the largest x. Capital Mi means it's a supremum. So the largest Mi which is rational could be 1 plus 1 by n only here. Similarly 1 plus 1 by n to 1 plus 2 by n, you can again see that this will be 1 plus 2 by n. So continuing in this way, for the ith interval 1 plus I minus 1 comma I n 1 plus I by n, my capital Mi is 1 plus I by n only, and this is 0, 0. So one can continue in this way and one can find out what is UPNF and LPNF. So let me calculate UPNF and LPNF. Okay, so my UPNF is summation I goes from 1 to n capital Mi xi minus xi minus 1. So this is same as summation I goes from 1 to n. My capital, this is my basically ith interval. So capital Mi is very clear, 1 plus I by n, and xi minus 1. So this difference you can need to find out. So 1 plus I by n. So this is xi basically, and this is xi minus 1 minus 1 minus I by n plus 1 by n. So that minus sign I have taken out. So plus 1 minus 1 will get cancelled. I by n minus I by n will get cancelled. So only 1 by n will survive. So this is equal to summation I goes from 1 to n 1 plus I by n 1 by n. Now this 1 by n is constant. We can take it outside. And now for this summation I goes from 1 to n 1 plus summation I goes from 1 to n 1 by n I by n, right? So 1 by, what is this summation? This is 1 plus 1 plus 1 plus how many times? N times, n times, plus this 1 by n is outside, so this is 1 plus 2 plus 3 plus dot 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 n, this outside n. So this is same as 1 by n. So this is 1 added n times, so n 1 by n. This is 1 to n addition, so n into n plus 1 divided by 2. So this n and this n will get cancelled. So I will have 1 by n. So n plus n by 2, that is 3n by 2 plus 1 by 2. So if I multiply n inside, I will get 3 by 2 plus 1 by 2n. So this is my u, p and f. So if I take this pn is in an n partition, then now today this uf is basically, if you find out this limit as n goes to infinity, u of pn comma f, provided this pn must be in n parts. So this will give me basically 3 by 2 plus 1 by 2n. So this limit goes to 0, so it will be 3 by 2. So I got uf as 3 by 2. Now for small mi, you can see that small mi is always 0. So L, P and F is anyway straight away 0. So this would imply LF is again limit as n goes to infinity, L, P and F, which is equal to 0. So I got LF as 0. So you can see that UF and LF are not matching, hence it is not R integrable. So UF is not equal to LF, hence F is not R integrable. Let me take another example, question number 2. Show that f of x is equal to 1 minus x belongs to interval 0, 1 is R integrable. So solving this won't be difficult, because showing R integrability, you either use the Riemann criteria, you find out UF, LF, both turns out to be same. And this Pn techniques, take the partition Pn and take from Pn you can find out limit as n goes to infinity. Limit as n goes to infinity, you can find out UF and LF and you can get it. One can also observe that this function is straight away, it is a polynomial between 0 to 1. It is basically, it will be a decreasing function. And it is being a polynomial, it is continuous and differentiable. So one can straight away say that one of the solution could be f is continuous on closed interval 0, 1. So how to show continuous? This could be homework. How to show f is continuous? You can think about this. The idea is, I'll just give a hint. You take any point P belongs to closed interval 0, 1 and show that f is continuous at P. So if it is f is continuous at P, further the f is defined on closed and bounded interval. A continuous function defined on closed and bounded interval is bounded. So f is bounded and continuous, hence f is R integrable. So this would imply f is R integrable, because we have proved one of the property that a continuous function defined on closed and bounded interval is R integrable. Well, one need to have explore the continuity properties and all, continuity. One need to recall continuity. Now, second solution is, let me calculate u, take Pn, the technique which I have used in a previous case. So that technique also will work out. So Pn 0 to 1 है, तो 0 first point होना चाहिए, 0 plus 1 by n, 0 plus 2 by n, dot 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 0 plus n by n, which is 1. So I think I just want to note here. So for example, if my interval is a comma b, then many times student asks us, and what pn I should take. So for those student, pn you supposed to take a comma a plus b minus a upon n comma a plus 2 times b minus a upon n comma dot 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 a plus n times b minus a upon n. You can realize this is n will get cancelled, a and minus a will get cancelled, so ultimately you will have b at last. So this will be a well defined partition. Okay, this is just general partitions p and how one should draw. So now with this I can go ahead, I have pn. So you can see that f of x, which is 1 minus x, this is decreasing function. As x increases, this is x, this is f of x. So as x increases, your f of x decreases because it's this way. So it's a decreasing function. So definitely is decreasing function. See, this is one more solution I can say. So one can show that it is decreasing, and if it is decreasing, then every decreasing function is R integrable. Monotonic decreasing function is R integrable. That is also one of the property which we have proved. So that could be another way, just two line proof. But since I am just giving you a thoroughly, one can write down this in exam, not an issue. You can get just one need to show then how it is decreasing. Maybe graphically when you can show, or you can show by if x is less than y, then f of x is greater than equal to f of y. That is another technique to show that decreasing function. Now why? So if it is decreasing function, then my capital Mi will occur at f. What is a capital Mi? Here one should note that it is supremum of fx such that x belongs to my xi minus 1 comma xi. So since it is decreasing function, so supremum will occur at starting point only. So it will be f at xi minus 1. Right. So what is f at xi minus 1? So it is 1 minus xi minus 1. Okay. Because f of x is equal to 1 minus x. So f of xi minus 1 is 1 minus xi minus 1. And now what is xi minus 1? That one need to understand, because this is x0, this is x1, x1 is 1 by n, x2 is 2 by n, x3 is 3 by n, xn is n by n. So xi minus 1 will be 1 minus xi minus 1 will be I minus 1 upon n. X1 is 1 by n, x2 is 2 by n. Yeah, that's true. And similarly, my small mi is infimum of my fx such that x belongs to xi minus 1 comma xi. Since it is decreasing function, so infimum will occur at xi. So f at xi, which is 1 minus xi. But what is xi? It is I upon n. I hope it is okay, because partitions this x0, x1, x2, x3. So even one can have this way chart बना के भी हो सकता है. This way also it is possible. But now I'm using some shortcuts. My UPNF is equal to summation I goes from 1 to n capital Mi xi minus 1. Right? So it is summation I goes from 1 to n capital Mi, just now I have calculated 1 minus I minus 1 upon n, and xi is I by n minus xi minus 1 is I minus 1 upon n. Okay, so let's calculate this. summation I goes from 1 to n, 1 minus I minus 1 upon n. This difference is basis same, so I minus I minus 1. So it is 1 by n, so 1 by n will come outside straight away. So I goes from 1 to n, 1 minus I minus 1 upon n. Okay, so let's solve this. This is not difficult to get the answer. So this is 1 by n. So summation 1 I goes from 1 to n minus summation, again this 1 by n will become 1, I to 1 to n, I minus 1 to, oh, this n will not come now. Right, so this is 1 by n, this is 1 plus 1 plus 1 added n times. This is for loop basically, n times minus 1 by n. So when I is equal to 1 it is 0, plus when I is equal to 1 it is when I is equal to 2 it is 1, when I is equal to 3 it is 2, dot 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 dot. When I is equal to n, then it will be n minus 1. So sum of first n minus 1 terms. So this is 1 by n. So this is n minus 1 by n. So first terms into n minus 1 into n minus 1 plus 1, that is n into n plus 1 upon 2. And the big bracket is also complete. 1 by n, so n minus 1 by n, so this is n minus 1 into n, so divided by 2. So this n will get cancelled. So what I left with, if I multiply this n inside, so okay, so if I multiply this n inside, let me check what I'll get. So it is 1 minus 1 by 2n plus, yeah, 1 by 2 because n will get cancelled, minus plus 1 by 2n. So 1 minus half is basically half plus 1 by 2n. Okay. Then my LPNF. So if my UPNF is cleared, UPNF is half plus 1 by 2n. So this would imply I can find out UF. UF is limit as n goes to infinity UPNF. Now one may ask that formula, this is formula is only used, we can use if Pn is of that form. अगर n partition कर गए तो we can use this formula. In general this cannot be. Delta के लिए ये नहीं होगा workout. So limit as n goes to infinity half plus 1 by 2n. So answer आएगा इसका half. इसका limit आएगा half. So I got UF as half. Once I have UF, can I find out the LPF now? So LPNF. Now what is small mi? I think I have calculated here somewhere. Yeah, it is 1 minus I by n. So now I am not doing the calculation. I am straight away writing what is LPNF. It will be half minus 1 by 2n. So one can check this. So if you find any difficulty, we will definitely discuss in the class. So my LF is limit as n goes to infinity LPNF, and that will turn out to be limit as n goes to infinity half minus 1 by 2n. So half is a constant, so ये half ही रहेगा. This will be 0, so answer is half. So I got UF as half and LF also half. So UF and LF are turn out to be equal, hence it is R integral. So LF is half, which is UF, which is equal to integral 0 to 1 f of x dx. So that is 1 minus x. So hence f is R integral. Is proved. So let me take one more example to have the clearer view. This is question number 3. I have f of x in the following way. It is 0, 1, x between 0 to 1, 1 at 1 it is discontinuous. So 1 to 2. So you can see that this function is discontinuous at 1. A function with finitely many discontinuities is R integrable. So this way is one of the. So question is, show that f is R integrable. Show that, or you can even write down, check that whether f is R integrable or not. Show that f is R integrable. So one of the shortcut answer, one can imagine that, or one can prove solution 1. F is discontinuous at x is equal to 1. So one should write down the justification, right? So I'm not writing that, assuming that you know why it is discontinuous. So that one should prove how f is discontinuous. So that is again a part, analysis part that we have done only in the first semester. So I don't feel that it is difficult. So implies, and we know that a function with finitely many discontinuities is R integrable. We know that a function with finitely many discontinuities is R integrable. So this would imply f is R integrable. Right, this is one of the solution, but then I want you to imagine just that delta solution. So let me have the another solution, or I will have a partition. Let p delta, I will take it as a partition. P delta is a partition 0, 1 minus delta 1, 2 minus delta 2, right? So choose delta such that delta is strictly greater than 0 and less than 1, assuming that. And let p delta be a partition of closed interval 1 comma 2, 0 comma 2. So you can even draw the graph of this. It is 0, 1 and 2. When it is step function, I guess. Yeah, it is step function. 0 to 1 it is 0 only. At 1 it is discontinuous, and 1 to 2 it is this one. So this is not step function because at 2 is equal to 2 hota hai step function, or एक point होना चाहिए, but then it's fine. This is 1. Okay, so I have taken this partition and now I will be defining an interval. So capital Mi is supremum. Now I am not writing, but if you are writing in examination, you must write down. And small mi is infimum of this, and here it is interval. So what kind of interval I have? If it is 0 to 1 minus delta, 0 to here somewhere I have 1 minus delta, here it is 2 minus delta. So 0 to 1 minus delta means this region. My function is constant as 0, 0, so it is 0, 0. then 1 minus delta to 1, 1. So at 1 it is taking value 1, so note that. So maximum value is 1 and the remaining times it is 0 only. So small value is 0. Then 1 to 2 minus delta, 1 to 2 minus delta, it is 1 and 1 again. And 2 minus delta to 2, it is again 1 and 1. So I can easily find out what is UP delta F and LP delta F. So UP delta F is equal to summation. So this is 0 into that small m1 into this 0 into 1 minus delta minus 0 plus this 1 into this interval ka subtraction. So 1 minus 1 plus delta plus 1 again and this interval ka subtraction 2 minus delta minus 1 plus 1 again 1 and this interval b minus that examined. So 2 minus 2 plus delta. Okay, so it is 0 plus delta plus this is 1 minus delta, it will be plus it is delta. So what I'll get is as follows, this minus delta, so 1 plus delta. So u p delta f is 1 plus delta, but we know what is uf. My uf is, it is infimum of all up delta upf, now I will say, such that p is any partition of closed interval 0, 2. Now this is very important, this is definitely less than equal to infimum of up delta f such that p delta is a partition of. Now why I wrote this, that is very important, because you must know this, there is a rule which we have studied. Now here the partition P is a larger subset of P delta, right? And we know if A is a subset of B, then infimum of A, uh, well, so if I apply infimum, then infimum of A is greater than equal to infimum of B, that one should know. So this way this UP delta F and this infimum property we have used it, and this is equal to basically infimum of UP delta F we have calculated as 1 plus delta such that delta greater than 0 and less than 1. So 1 plus delta such that delta between 0 to 1 इसका सबसे छोटा number होगा, lowest bound, greatest lower bound will be 1. So my UF is 1, UF is less than equal to 1, I will say, right? Similarly, I wanted to find out what is LP delta F. So LP delta F. Now again I am not solving because this table I have already written 0 0 1 1. So this LP delta F, that will turn out to be 1 now here. Yeah, so that you can check out, and then it is a constant anyway, so my LF is equal to supremum of all LPF such that P is any partition of closed interval 0, 2, and this is definitely greater than equal to supremum of LP delta F such that P delta is a partition of closed interval 0, 1, and this is equal to supremum of the number 1 only, where delta between 0 to 1. So constant supremum is 1. So you got this LF as greater than equal to 1. Well, have I got UF is equal to UP? I wanted to show that okay, F is R integrable. Okay, that's fine. So UP delta F mila hai, LP delta F mila hai. So I can use the Riemann criteria. So let me call this as number 2 and the above equation as number 1. Number 1. Right. So if I want to find out, so UP delta F minus LP delta F, this will be 1 plus delta minus 1, which is delta. So choose what I will say now. We can choose delta epsilon for every epsilon greater than 0, choose delta as less than epsilon. So this would imply UP delta F minus LP delta F is straight away epsilon, implies that F is R integrable by Riemann criteria. This would imply UF is equal to LF. But if you check at 1 and 2, so I should say LF is equal to UF. But one says that LF is always smaller than is greater than 1. So 1 less than equal to LF. So LF is greater than equal to 1. And 1 says that UF is always smaller than 1. 2 says that LF is greater than equal to 1. This is less than equal to 1. So UF LF lies between 1 to 1. That means they must equal to 1. UF is equal to LF equal to 1, which is equal to integration 0 to 2 F. Okay. So I hope such kind of problems even we have discussed in the class also, but then still I feel to have this question because the next question is based on that. So that is the last question of this session. So question number 4. So f of x is given to be 0 if x greater than equal to 1, less than 1. It is 77 if x is equal to 1, and it is 1 if x is between 1 to 2. Now check R integrability. Now instead of checking, one can easily check, one can observe that this function is discontinuous at 1, and a function which is has a finitely many discontinuities is R integrable. So this function is going to be R integrable. Now how to show that? There are many ways to get this. So one of the possible solution is as follows. One of the solution is, what I will do, I will construct g of x such that my g of x is 0 if x is greater than equal to 0, less than 1, and it is 1 if x is between 1 to 2. Now what you will observe in this is f and g are identically same except at one point. Which point? Because x at x is equal to 1, f is 77, and at x is equal to 1, g is 77. So everywhere they are equal except at 1. So here observe that f is identically g except at right. So we have proved one of the theorem, and we can see that g is R integrable. Just now the previous example, इससे पहले g is R integrable, and we have even seen the integration of g is 1, right? I hope it is 1 only. Yeah, just now we have seen. Yeah. So G is R integrable. So if two functions are identically same and they differ at finitely many points, or they differ at few points, then both functions are R integrable. This is one of the property which we have proved. So this would imply f is R integrable for the integration from 0 to 2, f is same as integration 0 to 2 g, which is equal to 1. Right, so this is one of the practical question I feel that I must take this up. So, or there is another way is that you find out, take the Pn partition, and then you have that. Could be a little lengthy calculations, but then you can always enjoy those calculations. So that's it for the today's. Thank you so much for attending the lecture.